in the unit number 8, the design of feedback control systems. In the last session, we will study about the phase, lead and the lag compensator using the root locus method. So first of all, as you know, what is the compensator? A compensator is an additional device or the network added in the feedback control system to compensate the deficiency in the performance of the system. So the adjustment of the feedback control system to meet the suitable or the given performance of the system, that system is known as the compensation. So using the compensator, we can modify the stability of the system. Okay, so today's our topic is design of phase lead compensator using the Bode plot method. So today we will study about the different steps regarding the phase lead compensator using the Bode plot. So what is the Bode plot? So Bode plot is also used to design the compensator network using the frequency response specification. Root locus is used to design the compensator using the time response specification. Now what type of frequency response specification are there? So the first one is the phase margin. It is known as the PM. Okay. Now the next one is the bandwidth. What is the bandwidth? It is the range of the frequencies. Now the third one is the error constant, and the error constant is known as the ESS, steady state error constant, and the fourth one is the same like steady state error. Okay, so using the Bode plot, we will specify this type of specification. Okay, now the design of phase lead compensator using the Bode plot. Now the step number 1, we have to obtain the uncompensated system Bode plot for the given value of the gain or the error constant. So in this example, they will given a transfer function like g of s, h of s is equal to suppose k upon s plus 1. Okay, so using this transfer function, first of all we have to derive the uncompensated system using the Bode plot method. Now whenever we design the uncompensated system, after that in the equation they will given the value of the gain like k is equal to something. Also they will given the value of error constant, and error constant is known as the Ka, Kp and Kv. So the value of the Ka, Kp and Kv is given. Using this value we have to obtain the uncompensated system Bode plot. Now next is step number 2. We have to find the phase margin of the uncompensated system. What is the phase margin? It is the angle of the system. So if it is not satisfied and the positive, then apply the lead compensation. Now what is the positive value of PM? Suppose 60 degrees is given, so we have to apply a phase lead compensator if the value of the phase margin or the angle is given like phi m is greater than 60. So the value of the PM is positive or greater than 0, then we have to apply phase lead compensation. Okay, now step number 3, we have to find the maximum phase lead angle using equation phi m. That means the maximum phase angle is equal to phi required. The value of the phi required is given in this question minus phi em, that we have to find in this step number 3 plus epsilon. Okay, so put the value of the phi required in this equation phi pm, and we have to find the value of the maximum phase lead angle. Okay, so always take epsilon is equal to phi degree, as high frequency slope is minus 40 degree per decade. So using the equation or using the transfer function, we have to identify what is the maximum frequency slope for the particular transfer function, and after that we have to decide the value of epsilon. Clear? Now the step number 4, we have to find the value of alpha, and the equation is alpha is equal to 1 minus sin phi m upon 1 plus sin phi m. Now what is the phi m? It is the maximum angle, so that we have to find in step number 3. So using the value of phi m, we have to find the value of alpha. Now the step number 5 is we have to find the maximum angular frequency at the magnitude. So the equation is minus 10 log 1 by alpha, and alpha that we have to find in the step number 4. Okay, so put the value of alpha in this equation and we can get this value. Now the step number 6 is we have to find the value of ZC and PC. What is the ZC? ZC is equal to compensated 0 and PC is equal to compensated whole. Okay, so we have to find the value of ZC and PC, and the equation for that, ZC is equal to omega m under root of alpha. The value of omega m and alpha is here, so put the value of omega n and alpha in this equation and we can get the value of nu 0, that is compensated 0. After that, PC is equal to ZC upon alpha. Put the value of ZC and alpha in this equation and we can get the compensated pole. Okay, suppose our equation is G of S, H of S is equal to K, that is our gain. Okay, upon S plus 1. Using the step number 1, we have to find the value of K. So suppose we can get K is equal to 2. Okay, and the new value of ZC is given, or we can get 0.1 and PC we can get 0.5. So now our new transfer function is become K is equal to 2. The value of ZC is equal to 0.1, so S plus 0.1 upon S plus 1, that is the uncompensated pole, and the new compensated pole is S plus 0.5. So this is my new transfer function. Okay, now step number 7, the compensator system is, as we know, G of S, GC of S, that we have to find K is equal to 2, the value of pole is equal to, 0 is equal to 0.1, S plus 1, S plus 0.5. So the transfer function is like that, G of S into GC of S. GC of S, that is equal to compensated transfer function. Okay, now summary of the phase lead compensator using the Bode plot. We have to find the value of phi at omega is equal to, we have to find the value of omega, we have to find the value of phi. So the equation is Pm is equal to minus 130 plus 180 is equal to 0, greater than phi required. The value of the phi required is given in this question. So we have to check whatever value that we have obtained is greater than phi required or not. If yes, then apply phase lead compensation, provide satisfactory phase margin. If this value is less than phi required, that time we do not apply the phase lead compensator. Okay, so summary, if phi m is greater than 60 degree, that time single lead compensator, such a large phase lead is not possible due to the component limitation too. So if the value of phi m is less than 60, that time we have to apply a single phase lead compensator. But the phi m is greater than 60, that time we cannot apply a single phase lead compensator. So that time we have to design a double lead compensator such that each section provides the maximum phase lead. Okay. So if Pm is not acceptable, that we have to find in the previous rule for that system stability, then we have to repeat the step number 3 with the new Pm. Okay, clear? So this is the phase lead compensator using the Bode plot. Thank you everyone. If anyone have doubt, then contact me in this mail ID.